This video deals with the programming of tools for the tool library of the Aplic 3000 control. In order to access the tool library, we do have to call up a program first. By pressing the program key, the list of programs in memory will appear. Touch any program. The profile shows up on the right, and press the base data. Every program has two steps of programming. Base data establishes tool type and material thickness, and the step data will identify the actual bend data. Let's go straight to base data. From the base data, we see the setup that has been programmed for this particular part. We see the profile of the part on the left, and we see the tool information here, top right, and the graphical representation here, of course. To access the tool library, you have to press this button here. When entering the tool menu, we are now given the punch, die, punch holder, and base list. All the necessary data will be listed here. If we take, for example, this tool here, we see that it is a gooseneck. The profile is there. We can edit, give it a name, a height, allowable load, V-angle, and so forth. All the standard tool information that you'll get right out of your catalog. If you wish to create a new tool, press the New button. Depending on how much memory space you're using up, this may take a couple of seconds. You will then be presented with a list of standard tool profile, or punch profiles in this case. You can select one of these standard profiles and edit as per the tool you have. This is a very common profile here. We can select this GP profile. At this point now, we can name it. Just press the name field. You can give it any name you like. The height of the tool is the height from the shoulder to the tip. Again, this is information that you will get from your tool library, your tool catalog, excuse me. As you will the allowable load in tons per foot, the V-angle of the punch nose, the tip radius, the tip length, which is the rear length here, the front size, which is the front flange of the tip, gap size, and then the rear angle, which is this angle here. Again, you can modify these, but this is data mainly for the graphic representation of the tool. What's really important is the height, the allowable load, V-angle, and tip radius. These are critical to the proper setup of the punch. Having input that information, you can now hit save, and that tool is now going to be in your list. Here it is here, test. Same applies to the die list. And we have a list of existing dies. Again, if we touch dies, we can see the corresponding profile. Note the 2V die. We're only showing one V at a time. We can't program both V's in the same profile. You're only programming one V at a time. Again, to create a new die, we start with the New button. We have a series of standard profiles. No shape, of course, will be a custom shape. A 2V, a single V, what they call the 1VDZ, and then the larger block sizes. Pick any profile, and you will be presented with the same menu as before. Name, height, allowable load, V opening, V angle, the shoulder radius, and the die width. The die width, of course, is important as it sets the safety zone for the back gauge so it doesn't hit the back of the tool. Enter data as required and then hit save, or in this case we'll hit cancel as we've not created a new one. Punch holder list. This refers to the upper tool holder, depending on how your machine is configured. These are standard profiles created by Aizawa. Select the one that's most appropriate to you. In most cases, with a standard punch holder list, the Aizawa software will present you with up to about a half a dozen different choices. In this case, because this machine only has one set of holders, this is why you only see the one holder here. And of course, the base list, the actual base you use to hold your tools. This is the most common one, obviously, for your 2V dies. You can create a new one, again, by pressing the new button. Sample profiles here, including what they call the no shape, again, where you can create one from scratch. Close this menu to return back to base data. The next video will deal with actually programming a part.